And one more ln example for you. Now, WebWork gives us an important hint on this problem. It tells us to try some substitution. It says, try letting w equal, w to be equal x plus 6. So what does that mean? It means before we do this whole integration by parts thing, which I'll show you how you're going to do in a second, it's tricky enough on its own, you need to make this substitution. So rather than the integral from 1 to 4 of the ln of x plus 6, we're going to be doing the integral of the ln of w dw. And an important thing, we don't know what the bounds are on this integral. We're going to need to convert back to x before we actually figure out what the definite integral is. So let's pick out our u and our v prime from this. So just like our ln thing before, now so notice the reason we're not just saying, well, the integral is 1 over x is 1 over x is actually the derivative of the ln of x. We want a function where we take the derivative and we get ln out. If we take the derivative of 1 over x, we do not get the ln of x. So what can we do here? The answer is actually an integration by parts. And what we'll do is u is equal to the ln of w. All right, so this thing here is going to be u, and remember the rest needs to be v prime. So this is going to seem very weird at first, but v prime is going to be equal to dw. So du, or u prime rather, is going to be 1 over w, and v here is going to be the integral of v prime, which is going to be the integral of dw, or you can even think of it as the integral of 1 dw. And that in this case is just going to be w. So remember the derivative of w is just 1, which is what I have here. Okay? So let's fill this into our formula. So the integral of u v prime is going to be equal to the integral of ln of w dw. So u and v prime here is going to be equal to u times v, so the ln of w times w, so u v, and then that's going to be minus the integral of v, so just w, times u prime, 1 over w dw. And so notice I started off with this integral that was a little bit too hard to do. And what I get here is actually an integral that's going to be very, very easy, right? So this is going to be the ln of w times w minus w times 1 over w is actually just 1 dw. And what I get out here is just w ln w minus, what's the integral of 1? It's just w. If I take the derivative of w, I get this 1. And this whole thing's going to be plus c. Now, my original problem was, what's the integral from 1 to 4 of the ln of x plus 6? And we said, well, you know, to do the ln of x plus 6, what I actually need to do is this substitution first. To get the answer to this, I need to bring back my x's. So this is going to be equal, this is going to tell me the integral of the ln of x plus 6 dx. I need to bring back the x's. So I'll have x plus 6, the ln of x plus 6 minus x plus 6, all plus c. And so if I want to do the integral from 1 to 4 of this whole thing, I can plug in the 1 and 4 here. So at x equals 4, I will get 4 plus 6 times the ln of 4 plus 6 minus 4 plus 6. And then at x equals 1, I will get 1 plus 6, ln of 1 plus 6 minus 1 plus 6. So if you plug this all into your calculator, you'll get about 6.404. Okay, and you can go ahead and type that into WebWork and it'll get you the right answer. Let me just remind you of a few keys to this problem. We started with an ln integral. The WebWork gave us an important hint to do a substitution first, and this integral is kind of hard enough to do on its own. Now, we only have a few methods to do integration. We have formulas, use substitution, and integration by parts. This is not the first two, right? There's no formula for ln, whether you think there is or not. There's no formula for the integral of ln. A use substitution here will not work. But what does work is integration by parts, and we need to pick a u that becomes easier to work with as we take derivatives. The rest of everything is our v prime. Then we just follow the formula. And we were not able to plug in this 1 and 4 into my w because this 1 and 4 are talking about x, right? So to deal with this 1 and 4, I needed to bring back the x's because of what I knew here about w's. I knew this about my x's. Just brought all my x's back in. And then I was able to plug in my x equals 4 and my x equals 1 and get the difference.